And in this class, in this very session, I'll be doing this number 4. Number 4. He said we should show that n factorial over n minus k factorial plus n factorial all over n minus into k minus 1 factorial k minus 1 factorial is equals to n plus 1 factorial all over n plus 1 minus k factorial. Alright. Without wasting much of our time, what do we know about factorial? What do we know about factorial? When they say n factorial, what does this mean? This is equals to n times n minus 1 times n minus 2 times times k minus 1 times k times k plus 1 times whatever. So let us, for easier comprehension and easier understanding, let n to be equal to 5. N factorial is equal to 5 factorial, which means 5 times 5 minus 1 times 5 minus 2 times 5 minus 3 times 5 minus 4 times 5 times 1, yeah. So now this is going to be 5 times 4 times 3 times 2 times 1. So this is what? 5 factorial. So now, if you have gotten, okay, let me not name it. If you have gotten this, now also, let me also do this. N is equals to 5. Now, n plus 1 factorial is equals to 5 plus 1 factorial. Alright, so now let's do this. Using mathematical induction, we want to show that this plus this is equals to this. We check P of 1. We check if P of 1 holds. Now, P of 1 equals, this is 1 factorial, and when we're checking for P of 1, when n is equals to 1, remember that we have k here. So, now, n equals to 1, k equals to 0. That is the first one we're going to check, and after this one we check for n equals to 1, k equals to 1. So for n equals to 1, k equals to 0, look at what we're going to have here. This is 1 factorial over 1 minus 0 is going to give us 1 factorial, and we'll have 0 factorial. 0 factorial plus 1 factorial all over. This is 1 minus 0 minus 1 is what? 1 minus into 0 minus 1. This is minus 1 times. So 1 minus 1 is 0. Correct? Yes. 1 minus 1 factorial. This is k minus 1. Which is what? 0 minus 1 minus 1 factorial. This is going to give us 1 plus 1 factorial all over what? This is 1 plus 1 to give us 2 minus 0. That is 2 factorial, 2 factorial, 0 factorial. Now, if you remember factorial, you know that 0 factorial is equals to 1 and 1 factorial is equals to 1. If you don't know it, you go back and check it. But you observe that we have negative sign here, and the factorial property is not defined in the negative part of the real number. So this will make this entire thing to be undefined. And when you are adding 1 to infinity, it is infinity. So adding anything to undefined means that the whole of that entire operation is what? Undefined. Alright, so the next one we're going to check now is 1 when P of n equals to, okay, P of 1, this is n equals to 1, k equals to 1. So now, we are still in P of 1. We have n equals to 1, this is 1 factorial all over 1 minus 1 is 0 factorial times 1 factorial plus, this is 1 factorial over here. We have 1 minus, this 1 minus 1 is 0, 1 minus 0 is 1 factorial, 1 minus 1 is 0 factorial is equals to 1 plus 1 is 2 factorial all over, this is 1 minus 1 is what? 0 plus 1, that is 1 factorial times 1 factorial, 1 factorial. So what we have here now is what? 1 over 1 plus 1 over 1 is equals to 2 over 1. Implies that 1 plus 1 is equals to 2. So here, for P of 1, implies the left hand side is equals to the right hand side. So it holds. Since P of 1 holds, comma, we assume that P of n holds and show for P of n plus 1. So now, for P of n plus 1, we have for P of n plus 1, okay, here we have n plus 1 factorial all over. Whenever we see n, we replace it with n plus 1. So this is n plus 1 minus k. This is n plus 1 minus k factorial. K factorial. Now plus, this is n plus 1 factorial all over. Here is n plus 1 factorial. N plus 1. Here is n plus 1 minus k minus 1 bracket close factorial k minus 1 factorial is equal to, here is n plus 1 then plus 1, n plus 1 factorial all over. Here is n plus 1 minus k, n plus 1 minus k factorial. Alright, so now the next thing we do is, here is n plus 1 factorial all over n plus 1 minus k, n plus 1 minus k factorial plus, here is n plus 1 all over. This is, when you open this bracket, here is minus times plus is minus, minus times minus is plus. So here is n plus 1 minus k. That is n plus 2 minus k factorial, k minus 1 factorial. This is equals to n plus 2 factorial all over. This is n plus 2 minus k factorial, Alright, so now the next thing we are going to do is to look for the LCM of this and this. Yes, you say look for LCM. What is LCM? We are going to look for the LCM. Now, I want you to, from here, okay, check that n plus 2 factorial is equals to n plus 2 multiplied by n plus 1 factorial. Now, remember I said let n equals to 5. N plus 2 is equals to 7. And 7 factorial is equals to 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, n plus 2 factorial, which is equal to 7 factorial, is equals to n plus 2 multiplied by n plus 1 factorial, which is the same thing as 7 as our n plus 2 multiplied by 6 what factorial. You see that they are the same thing. So since they are the same thing, you will agree with me that n plus 2 minus k factorial is equal to n plus 2 minus k multiplied by n plus 2 minus n plus 1 minus k factorial, which is what we have here. So, since this one is inside this one, we don't need this one again. This one has covered this one, so what we have here is n plus 2 minus k factorial. Now, n factorial is equals to n into n minus 1 factorial. For example, our n is 5. 5 factorial is equals to 5 times 4 times 3 times 2 times 1. And the n minus 1 is equals to 5 minus 1, which is equals to 4. So n minus 1 factorial, in this case, is equals to 4 factorial. So now, so n factorial is equals to n into n minus 1 factorial. 5 factorial is equals to 5 into 4 factorial, which is the same as 5 times 4 factorial, and it's going to give you the same thing. Where am I going? Where I'm going is here we have k factorial and here we have k minus 1 factorial. You see that k minus 1 factorial is under k factorial, so we don't actually need this. So what we're going to need is k factorial. Since we have gotten k factorial, we are going to okay, let me make it more easier. I'll have n plus 2 minus k into n plus 1 minus k factorial k into k minus 1 factorial. So when I divide this by this n, the whole of this one now is k factorial. So this has covered this. When I divide this by this, I will have n plus 2 minus k. So I have n plus 1 factorial into n plus 2 minus k plus, now the whole of this one here is equals to n plus 2 minus k factorial. So this one is only k. When I divide, I have only k. So this is, factorial. N plus 1 factorial multiplied by k. Alright. Okay. Alright, we are moving. Let me clean this place and continue. Yes. Alright, so with that I have n plus 1 factorial into n plus 2 minus k plus n plus 1 factorial times k all over n plus 2 minus k factorial minus k, then I have n plus 1 minus k factorial multiplied by k into k minus 1 factorial. Okay, this is what I have. Now I'm checking if I'm going to get what is in this right hand side. So now look here and look here. You see that n plus 1 factorial is very common. So you bring out n plus 1 factorial. So here n plus 1 n plus 1 factorial bracket open, we have n plus 2 minus k n plus 2 minus k plus k. Yes, minus k, then plus k all over. Let me just shrink this one. I will now have n plus 2 minus k factorial k factorial. So now, okay, this is equals to n into n into n plus 1. What I have is n into n. Did I make a mistake? No. Okay, n plus 2 factorial. Okay, so what I have now is n plus 2 into n plus 1 factorial all over n plus 2 minus k, n plus 2, n plus 2 minus k factorial, k factorial. Now, this n plus 2 multiplied by n plus 1 factorial, this is actually going to give us n plus 2 factorial all over n plus 2 minus k factorial, k factorial, which is actually what we have in the right hand side where we check for p. This is actually what we have here. Actually what we have here. So we now say thus, comma, it is clear, because it is clear that the whole of this is equals to this. I'll call here H, I'll call here I. It is clear that H is equals to I. And this concludes our proof. I remember the certificate of Timothy actually. I've done justice to these 4 exercises. So, if you have any question, you have any input, any suggestion, any correction, do well to leave them on the comment section below. Share and subscribe. Thank you very much. Let me make my screen.